Hi, I'm Sema Jonathan. This is my final project for the course Managing Machine Learning Projects from Duke University Coursera. Our first task is to evaluate opportunity. My problem statement is think about a company which requires a more security way to access to the company and control systems. Today they use key cards, but unfortunately that brings security risk with lost key cards or stolen or employee shared cards between them. And when employees forget their key cards, that cause more administrative work. So as a result, more secure, efficient, and user-friendly access control system is needed to ensure that only authorized personnel enter office premises. So for this problem, can machine learning help us? Yes. For machine learning for face recognition models can provide an effective solution because facial recognition technology can uniquely identify employees and grant access them. And also machine learning can learn and adapt to different lighting conditions, facial angles, and minor facial variations. And also anti-spoofing techniques, so if this person is live or not, prevent unauthorized access attempts by using photos or deepfake attacks. Does someone care this solution? Yes. Companies' security teams will benefit from this solution by strengthening office security and prevent unauthorized access. Also, employees will have benefit with a smooth key card free entry experience. Our second task is define the problem with CRISP DM model. To define the problem, let's start with target user. My target user is office employees, security teams, and facility managers in organization that require controlled access to secure areas. And my problem statement I already mentioned in the previous slide. So today they use key cards. They want to switch to a more secure way to grant access to the office. And why it matters? Because of the security risk, again we mentioned in the previous slides, because of this unauthorized to prevent unauthorized entrance into the office by using these stolen or lost key cards. And also when employees forget or misplace their key cards, that cause delays and administrative overhead. How it is solved today? Today they use key cards. And what is the gap in the current states? Key cards can be lost, stolen, or unfortunately they shared them. Employees shared them. And define success. So my expected business impact for this one: prevents unauthorized access, increase operational efficiency by reducing reliance on physical access tools, and minimizing delays. And of course, better user experience by providing a seamless and contactless entry process. I have some constraints, which are privacy regulations. So this data must be stored and processed very securely and encrypted. And model accuracy requirements. So we must be sure to minimize false positives and false negatives. And integration with the existing system should work alongside, these solutions should work alongside current security infrastructure. And what are my outcome output metrics and success targets? So my outcome metrics will be reduction in unauthorized access attempts and decrease in keycard related security incidents. And output metrics will be face recognition accuracy, so recall false positive negative rates, and system response time for face verification. Relevant factors for this problem will be, of course, lighting conditions, so it must work in different office environments. Face variations, model should handle, my machine learning model should handle different angles, expressions, or obstructions. We should be aware of hardware limitations, so processing should be efficient for real-time verification since we need this immediate decision. And user acceptance, employees should trust and feel comfortable using face recognition for entry to office. So my solution concept will be, there will be a camera at the office entrance, captures the face of an employee. We will pre-trained deep learning model compares the image to a database of authorized employees. And if a match is found, then we will grant access to them. Otherwise, we will keep the doors locked. A validation plan. So I plan to have a test on a small data set of employee faces to evaluate accuracy. Then I will introduce real world conditions like different lightening angles or small changes in the faces like having a beard or long hair. And then I will deploy in controlled environments. So if my customer have more than one office, then we will use in the only one office as a pilot. But if we have only one office, then maybe we can use different entries or different time slots to use this solution and test it. Then we will collect feedback, and then we retrain our model to get the perfect results. Machine learning system design. So our next task is to design the machine learning system. So it will be edge processing because we need immediate response without relying on network connectivity. And of course, it ensures better privacy since this data will process locally and doesn't need to be transmitted to the cloud. And it is more secure against cyber threats since data doesn't leave the office premises. And it will be offline learning because face recognition model can be trained on a predefined data set of employee faces and then deployed. Online learning is unnecessary unless new employees are added or drastic environmental changes occur. And it will be online prediction because decision must be made in real time as my employees arrive. And a batch system, of course, will not be feasible because our users, employees, expect instant authentication to enter the office. And the last part is potential risk in production. So we might have some possible problems like first one is training serving skills. So model might perform well in controlled training environment, but it might fail in real world conditions. So possible problems can be difference between training images and real world office conditions. So like camera angles and lightings. Employee appearance changed over time due to hairstyle, facial, makeup, glasses, and even aging. And data augmentation techniques used in training may not fully capture real-world variations. So as a solution, we can regularly update the model with new real-world images and use domain adaptation techniques to improve generalization. Second possible problem might be latency issues. So it is very important to get the immediate decision from the model. Delays in face recognition can create bottlenecks at the entry points, and the main reasons for this problem can be high computational load on edge services or large model size causing slow inference time. So for this one, solution can be implementing caching mechanism for frequent users, maybe to speed up recognition, and using, of course, edge processing to reduce reliance on network connectivity. We already mentioned that we will use edge processing for this one. Next one, data drift and concept drift. Over time, the model may become less accurate due to the changing data distribution. So from data drift perspective, that might lighting change, new camera placement, or environmental factors affect image quality. Or from concept drift, scope, employees aging, changing facial features, like as I mentioned before, growing a beard, or new employees not resembling the existing data set. So for this one, possible solutions: periodically retrain the model, so we should keep retraining it with updated images, and also we should implement continuous monitoring to catch the errors or flag the performance degradation. And the final one is security risk. So attackers for this is the main problem with face recognition. Attackers may attempt to bypass security by using photos, videos, or deepfakes. So to prevent this risk, we can implement liveness detection, like blinking or infrared cameras. We can use multi-factor authentication in high security areas, maybe. But the most important part, due to privacy concerns, we should ensure GDPR compliance by securely storing and processing the facial data. This is all about my project. Thank you for listening, and thank you for evaluating my project.